Hello and welcome to the second lecture of Symbolization and Introduction to Logic lecture 10. So in this lecture, what we will be discussing? We will be discussing only two symbolization patterns. The first will be that of an implication and second will be that of an equivalence. Now implication, which is represented by a horseshoe and simply understood as an if-then function, is the most important and most diversified symbolization of logic, because in natural language it can be represented in many ways, and we need to understand its symbolization properly. Now, before going to the symbolization of implication, I will give you a couple of informations, or I will provide you with a couple of informations regarding the and the or function, which we just discussed in the last class. If you remember, the and function as well as the or function, which we discussed in the last class. So if some questions representation is p dot q, or some questions representation is p wedge q. So if for p dot q you write as, say, q dot p, or if you write p wedge q as q wedge p, so they will not have any problems, because p dot q as well as p wedge q both follow the rule of commutation. And as you know, the rule of commutation, which we will be also discussing in the rules of replacement in the later part of this course. So you will understand that p dot q is equivalent to q dot p, as well as p wedge q is equivalent to q wedge p. Now this is helpful, and the thing is that if there is a question whose symbolization is p dot q and you write it as q dot p, so you will get full marks, right? Because it is an equivalent expression. So similarly, if there is a question which has p wedge q as its symbolization and you wrote q wedge p, again you will get full marks, because again it's an equivalent expression. However, in case of implication, it is not true. So let us first discuss how a simple implication is represented. Like, suppose if you have an expression like if p then q. So what is going to be its symbolization? Most of you will say that it is p implies q, and this is the right answer, and this is the simplest expression of p implies q, right? It can be written in another way. Like, suppose if a statement says p if q. Now what will be its symbolization? The symbolization of this one will be q implies p, and this p implies q and q implies p are not equivalent expressions. In fact, to tell you, p implies q is equivalent to negation of q implies negation of p, which we will be discussing at a later part of our syllabus. But right now, for the time being, you should understand that these expressions are equivalent, but if you write q implies p, this is not equivalent to p implies q, right? So this needs to be understood. So as I told you in the a few minutes back, that if p dot q is represented as q dot p, or if p wedge q is represented as q wedge p, there is absolutely no problem. However, if p implies q is represented as q implies p, then there is a problem. And you can see, if this expression in English, if you understand p if q, what does it says? It says that it is if Q then P. This is the expression, right? So in English language, people can write or people can say a sentence which will be grammatically proper, like if P then Q, right? So it is P implies Q, but they can also say P if Q. Or they could have also said Q if P. If suppose they would have said, I will remove these two, and if suppose somebody says Q if P, then it is exactly the same as above. That is P implies Q, right? So this is also something which you need to understand. This is not all about if-then function. There can be a condition like this. Like, let me take a couple of conditions and see how you are planning to react to it. Like, if there is a sentence like this or a statement like this, P is a necessary condition for Q. The next says P is a sufficient condition for Q. So if this is the first sentence and this is the second sentence. So what is going to be the symbolization? You can pause this video and check for yourself that what is going to be the symbolization for both of them. One hint which I can provide to you is that both of them do not have the same symbolization, right? So this is something which you should understand. Now you can pause and check for yourself. Okay, now let us see the analysis of what your answer is. P is a necessary condition for Q. So it is symbolized as Q implies P. If it is said P is a sufficient condition for Q, then it is symbolized as P implies Q. Now, how to understand this sufficiency and how to understand this necessity? A few lectures back, we also discussed validity and soundness, right? That an argument is sound if it is valid and if it has true premises as well as it has true conclusion, right? So validity is a necessary condition for soundness, right? But validity is not a sufficient condition for soundness. So if an argument is valid, will it be sound as well? No. But if an argument is sound, then will it be valid? Yes. So this understanding needs to be clear in your mind. Like suppose if I can give you another example. Like 12th board examination is a necessary condition for pursuing engineering, right? So if suppose you have passed 12th board examination, is it the case that you are pursuing engineering? No. But suppose if you are pursuing engineering, then have you passed 12th board examination? Yes, right? So this has to be your understanding of necessity and sufficiency. So this also is an important thing which you should remember, that how to symbolize propositions when it comes to implication. Let us take few more examples. There are ways through which you can actually represent this if-then, right? Like there is a condition like this: P only if Q. P when Q. And there can be another one: P provided that Q. Now, what will be the symbolizations of these propositions? Let's start with the last one. P provided that Q. So it talks about like P will take place if there is Q, right? Because provided that Q, right? So the class will take place provided that students come to the class, right? So if the students come to the class, then only the class can take place, right? So P provided that Q, the symbolization is Q implies P. P when Q. It is also like this. When Q, then P, right? So the symbolization of this is also Q implies P. Now I will ask you to stop the video or pause the video and check for this one. P only if Q. What is going to be your answer? Because it is an interesting one. Now you can pause the video and check for yourself. Now let us see the analysis of this one. Many of you may say that it is P implies Q. Many of you may say it as Q implies P, right? Now what is going to be the symbolization of this? P only if Q. If you see, it says this only if gives or makes something a necessary condition. Now you remember from the last examples that when we took P is a necessary condition for Q, P is a sufficient condition for Q. So it is always sufficiency which implies necessity. This needs to be understood, right? So something which is the sufficient condition. If you remember, let me tell you, when we say P dot Q, so we call these two as conjuncts. Fine. When we say P wedge Q, so these two are called disjuncts, because one is a conjunction, the other one is a disjunction, right? Now when we say P implies Q, fine, when we say P implies Q, then this is called as an antecedent, and this is called as a consequent. Fine. Okay, because these are certain things also which you need to understand. So it is always antecedent is the sufficient condition and consequent is the necessary condition. Fine. So when we say P only if Q, and this is a little bit counterintuitive, usually people have some problems representing P only if Q. The symbolization is nothing but P implies Q. Only if tells that it is a necessary condition, and since it is a necessary condition, it goes to the other side, and the sufficient condition, that is Q, P only if Q, this only if Q, this Q becomes a necessary condition, and as you can see that the necessary stays at this part. So even if you feel like that it is like P if Q, but it is not actually P if Q, it is P only if Q. So what is the necessary condition? This becomes the necessary condition. If this would have become the sufficient condition, it would have gone in this side, but since this is the necessary condition, so it stays over here. So P only if Q, the symbolization is simply P implies Q. So this idea also needs to be understood by you. Okay, we have enough of discussion and enough of ideas regarding how to represent or how to symbolize implication. There can be a few more, and if it will come, we can discuss. Like there can be a simple one. So let me discuss that one as well before going to equivalence. Like assuming P Q, something like that, or P assuming Q. So assuming P Q, assuming P comma Q, sometimes this is represented assuming P just Q, sometimes this can also be the case. We will take the examples in the exercise section. This comes as P implies Q. And when say P assuming Q, so this becomes the sufficient condition. So this is Q implies P. So these kind of cases or these kind of representations also come, these kind of questions also come, that how to represent implication and what are the markers of implication. It's a little bit tricky sometimes, but the more you will practice, the more you will take questions from different books and from different parts, and also will be attending the exercise sections, so it will become more clear. Now let us come to the last part of our symbolizations, and that is equivalence, right? So you know that equivalence is represented with 3 bars, triple bar, and it is a function like if and only if, right? So if you say a sentence like this, P if and only if Q, so it is a conjunction of 2 sentences, P if Q, and P, and I can put it like this, and P only if Q, right? So these are 2 expressions for it. Now you know the symbolization of this. It is Q implies P, and it is P implies Q, and this expression becomes P triple bar Q. So if and only if, which is an equivalence condition, is actually represented in this fashion. So P triple bar Q is like P implies Q and Q implies P, or Q implies P and P implies Q. You can put this part here and this part here. As I told you, that conjunction is a commutative function, so you can change the positions. However, we have still not introduced to you all these things, therefore I am not discussing them in length, but you can always do this, right? So Q implies P and P implies Q becomes P implies Q. It can also become P equivalence Q. It can also become Q equivalence P as well, right? So you can change the position of this over here and this over here. Still, it will remain the same. There is another expression. Another expression for, there are in fact few more. So let us discuss all of them. What will be the other expressions for equivalence? Another expression as if and only if can also be written as IFF. This is not something which you are not aware of. Students of mathematics, students of computer science, students of engineering do understand what is IFF. However, people from philosophy usually refrain from using this IFF symbol. They use the if and only if expression complete, in incomplete sense, or incomplete, they will write it fully, right? So this is certain conventions which students and logicians follow across the world. If P is a necessary and sufficient condition for Q, this is also P triple bar Q. You can also write it as Q triple bar P. There is absolutely no problem. So this is another expression for equivalence. There is another expression, P exactly on the condition for Q, or on Q, or of Q. Sometimes it is written in different ways. So this expression is also P triple bar Q, or you can write it as Q triple bar P. You can write it any one of them. So both of them will be P triple triple bar Q or Q triple bar Q. Q triple bar P. So you understand that what will be the expressions, or what are the markers which we need to understand. If there is a sentence or a statement which is having if and only if there is a proposition which is having necessary and sufficient condition, if there is an expression which says exactly on the condition that, or exactly on the condition for, sometimes it is also written as that, exactly on the condition that, sometimes, in fact, this is more proper. So in these cases, you will find that we will be symbolizing these as P triple bar Q, right? There is one more, but then it is a little bit tricky one. Let me take this example. So that we can understand that how we will be representing it. The example goes like this. I will not close the shop except if it rains. Now suppose this question comes, then how will you symbolize it? And this is not a very easy question. Okay, first thing, you need to pick up this, that there is a not, and there is also a marker called except, and you also know about if, but there is no then. So whenever you face this kind of problem, and in the later part of the course you will be having a little bit more complex symbolizations which we will be solving in the predicate part of the predicate logic. So you will find more questions, more interesting, more challenging questions. So let us understand how we are going to symbolize it. Now, whenever you find a question like this, then what should be our strategy? Our strategy should always be that how to understand that what this proposition says actually, because that is going to be an important thing for us, that what this proposition says, and then we will be symbolizing it as per what this proposition says, because sometimes it may have certain things like the example in which not only but also came, we found that there was a not, but then that not was not a negation, it was basically a conjunction, right? So these things we need to pick up, that what that proposition actually wants to talk about, or it is saying, right? So that needs to be understood. So it says that, suppose there is a shop owner, he says that I will not close the shop except if it rains. So what does he, the first thing which you need to understand, except is a triple bar. So there will be a triple bar expression. Now suppose if I divide this into P and Q, what will be P? I will close the shop, because I will close the shop will be a simple proposition. There is no negation over here. So this is the first thing which you should understand. Second, it rains. So this except and this if together makes this equivalence sign, right? I will remove this so that you are not confused. So the equivalence sign comes precisely because of except if, fine. Sometimes the expression of except only is used in some kind of propositions, whatever. You need to understand the meaning. Now suppose I symbolize it like this, negation of P, triple bar Q. Okay, let me check whether this conveys the meaning of this, because that is what the symbolization has to be. So what it says, I will close the shop. Here it says I will not close the shop. Equivalence, it rains. Fine. So what it is saying, it is saying that I will not close the shop is equivalence to it is raining, right? However, in question, if you see, it says I will not close the shop except if it rains. It means that the shop will be closed only when it will be raining, right? That means if the shop is closed, it means it is raining. If the shop is open, that means it is not raining. That is the understanding which this sentence is trying to tell us. So even if now if you see this expression that I will not close the shop, because this says that I will not close the shop, and here it means that it is raining, so this is not giving the expression. Suppose if I remove this, what does it says? I will close the shop is equivalent to it is raining. It rains or it is raining. You can also make this as it is raining. Fine. Now if you read this, that I will close the shop is equivalent to it is raining, which is actually conveying this expression. Even if there is this not, I have not used the not for the simple proposition. I have removed that, right? And I put the negation over here initially, but then I saw that the meaning is not yet conveyed properly. So when I use this expression, I will not close the shop except if it rains, what I am trying to say is that only if and only if it is raining, then only my shop is going to be closed. If it is not raining, then my shop is open, right? So maybe that shopkeeper is traveling from some distance, and if it is raining, he is not coming or he is not able to reach his shop because of the rains, because of the muddy something and this and that. Therefore, he has made that statement, right? So you need to understand the language as well to represent the proposition, right? So there are definitely certain standard markers, but there are also sometimes some non-standard markers as well, or maybe I may not use the expression non-standard, rather some markers which needs to be dealt with lot of care. So think about this question, and if you have more symbolizations like this, you can always put as comments, and we will be discussing in the class. So thank you very much again for watching.